Всім добрий ранок. Трошки зачекаємо на пані Надію. Будемо починати вже згодом.
Добрий ранок.
А ще одразу скажу, розумію, що ситуація непроста, багато там надзвілих проєкти групові. Якщо раптом щось сталося, або ви не змогли закрити час, або у вас тіммейт відвалився, або щось типу того, то готуйтесь розповідати свій хід думок, як би ви вирішували це завдання, якби у вас була можливість. Це, типу, замість основного іспиту з презентацією, пічингом результатів проєкту.
Доброго ранку всім. Перепрошую за запізнення.
Доброго ранку.
Доброго ранку, Дмитре. Доброго ранку всім студентам. Так, я бачу, що так. Є вже всі представники групи, яка буде першою презентувати. Ще не вистачає когось.
Напевно, ми будемо перші.
Так, прошу.
Ну, нас було зразу 4, але 2 відвалилися в нас в групі. Тому
Ага, зрозуміло.
Угу.
Зрозуміло.
Так. То, в принципі, вже можна починати?
Так, я думаю, що можна. Дмитрий, чи може може ви щось говорили, я вас перебила своєю появою?
Я казав, просто наголошував тому, що хто раптом не підготував результати і презентації до пічингів, просто щоб були готові розказати хід думок по вирішенню проєкту. Ну, типу, задачі конкретно, яку обрали би, або обрали, і не змогли ви вирішити за певних обставин.
Саме так. Чи можете починати?
Так, окей. All right. So I think I'll talk in English. So okay, so to go through our project again, the idea is to do license plate detection and OCR. So again, we have a data set that consists of 433 images of different cars with their license plates visible. Some images contain more than one visible label. And so as for the model that performs object detection, we didn't really change that much. It's still YOLO v5. And yeah, so again, just to refresh the memory, it gets the best performance it got was MAP of 0.8 and precision of 0.82 and a recall of 0.85. Okay. Then here's an example of how it worked. Then now as for OCR, so we decided to look into 3 different approaches, or like rather 3 different tools that we can use for OCR. So PyTesseract, which is basically like a Python library that uses a tool called Tesseract, is one of them. Then there's Easy OCR and Battle OCR. But before we get to them, firstly, we created a data set that we would use to evaluate how well those toolkits did. So we picked 75 different images and manually went through them and wrote what is the correct license plate number. And basically, here's an example of how it looks. It's just the file name, and here's the most important part: license plate. And then also we came up with a metric that kind of evaluates how well we recognize the number, which makes use of Levenstein distance, and it's basically from 0 to 1. And if it's 1, it's a perfect match. Yeah. Now, as for the tools themselves, here we have the architecture of Tesseract. It's a bit confusing to look at, to be honest. And yeah, well, we didn't really go too deeply into understanding how it works, but we looked up these visualizations of how they work. This is ECOCR. Well, it seems a bit, maybe a little bit more complex. And Petal OCR, I think, is the most developed one. It's some Chinese. I think it's made by a Chinese company. But yeah, it actually turned out to be the best one as well. So back to PyTesseract. So after using it on every image of that dataset that we did, we got results that look somewhat like this. So out of 75, it only evaluated or read correctly about 10 images, and there were a lot that were well, just very wrong. So like images that were like over here somewhere, they were just like maybe a couple of letters were incorrect. And here's examples. Well, here's an example of when it read perfectly. Like it's pretty obvious as well. And if we go lower, this is like 0.83 score. There's one more 6 than. Oh, actually no. Apparently this is a mistake on our part. This should be 1. But let's say over here, yeah, over here, this I shouldn't be here. And lower, we have examples of all this. This is like just the letter 2 or the number 2 was correct. So yeah, that's PyTesseract. Easy OCR, well, we did the same thing with it, and here we can see results that are way better. So over 25 images out of 75 were read perfectly. But there were actually some that were almost identified perfectly. So we could say that maybe like 2/3 of it were above 0.5 score. So yeah, there's some examples. This is still score 1. Here there's just 7 being labeled as Z. And yeah. Yeah, there's W and M and so on. Now, Battle, again, it performed the best. And this one actually over like almost 45 images out of 75 got a perfect score. So yeah, this tool is a lot more advanced, and well, my assumption is, I guess Chinese hieroglyphs have they kind of need the model to be a lot better to to recognize Chinese letters. So maybe that's why. But yeah, here, like if we go all the way back, all the way down here, we still have score 1. So yeah, these outputs I sorted all of them by score. Yeah. Let's look at some examples of where it didn't read perfectly. Oh yeah, so I don't know what this was, to be honest, but oh right, so yeah, actually it tried to read something, but failed a little bit. Like for example, the A and the numbers in the end. Yeah, and well, after this we put together like the final pipeline in the form of like one function that takes an image and optionally the OCR method to use, and returns a list of licenses. Well, already like text of licenses. Yeah, and somewhere in here it uses YOLO v5. Oh yeah, and so for this task we found some real images from Ukraine and tested it on this. So yeah, let's look at them. Yeah, I don't know what this car is doing here. It's very old, but yeah, here's an image like this. Here you can see we can see the real ones on the image, and we can kind of compare how well our detection did in terms of how many items we have in the list. So so obviously this function now it uses the model. So it uses the output of object detection before applying OCR on them. So here we have 2 items, and well, the first one is the easiest one, so it's a perfect match. And this image, this license plate over there is a lot blurrier. So so like we can see how Tesseract tried to make out something, but it failed. Easy OCR did a little bit better. It got the EI in the end. And Paddle OCR did the best and did it perfectly, actually. Here, there's a bit of a more difficult image because it's more slanted and it's also red. So here, Tesseract didn't do anything at all. It couldn't read any text. But again, Paddle OCR did almost perfectly, only mistaking S for a 5 or 5 for S. Here's an image of 2 cars, and here actually apparently this license plate over here was really hard to read, and somehow EasyOCR actually did better in this one. Like it read at least something. So so I guess that shows that Paddle isn't better than EasyOCR on like on all fronts. And here's an interesting example of where our object detection didn't work perfectly, because one of the bounding boxes is on the ambulance text, which I guess kind of resembles a license plate, but after all, it's not. So yeah, that's a mistake. But the license plate was actually recognized perfectly here too. And the last one, we have 2 cars with 2 license plates. And here, this one was more difficult to recognize, but Paddle almost did it perfectly, except there's only one A. Yeah, and that's about it. Now, as for further improvements that we can do in the future, so here are a couple that we could think of. Firstly, obviously training on a data set that is specific to the region or use case that we're going to use the model in is going to be a lot better. So like here we had a data set with lots of different images from all over the world, probably. So maybe that would be better for using a model that would be worldwide as well. But if we only use it in Ukraine, it's better to collect our own data in Ukraine. Also, applying transformations to like regions within the bounding boxes. It's probably gonna so I think OCRs are gonna improve better if, like, for example, we apply homography to like straighten some of the license plates or like fix the perspective. For example, this one right here is very slanted, and maybe because of that it was very difficult to read it. And also things like changing the colors or improving sharpness. And also, well, so far we only use the OCR models that were already trained. So maybe training OCRs or on our own data could also further improve their success rate. Yeah, and that's about it. Thank you for listening.
Thanks, Taras. Like, really nice presentation. I enjoyed, honestly.
Thank you.
I see the rest of the similar opinion.
Yeah.
Okay, let's start with some questions. Okay, I will let Dmitro start.
I start first.
Yeah, go ahead, go ahead. I know
Okay.
that you will probably have more technical questions, and then like, so like, if you didn't cover something, I'm going to cover.
Yeah, okay, sure. Once again, thanks, Taras, for the great presentation delivery. I'll just give an overall feedback for the impressions of mine. First of all, like, really great job experimenting with those different OCRs and showcasing and demonstrating how each one of them works better, worse in some cases. Yeah, I'll have some questions for maybe your intuition behind why some of them work or not in certain cases, but that's later. And basically just yeah, very nice baseline with using YOLO v5 and not like going in depth into some kind of other sophisticated architectures. Pretty good choice for the data set, and like not having too many images to work on and like fine tune on. Probably your inference time is also kind of is sufficient enough to run through all those. So yeah, that was really good. And as far as questions go, just yeah, the first one is of course towards the object detection part. So YOLO v5, which model did you use? Which size?
Medium size.
Medium. Okay, and did you fine tune it at all, or just use? But yeah, I know you did fine tune, but how much of a work did you like? How much of an effort did you put into high parameter tuning?
We didn't really put in much effort. I mean, we just ran it through training once.
Mm-hmm.
That's yeah. That's all we did.
How much did it take? 0.7 hours. Is that for all epochs? Oh, for all iterations?
It took
this for one.
So for all epochs, it took I think
less
43 minutes.
Mm-hmm. Mm-hmm. Okay. Mm-hmm. And you got like a very decent recall and precision and MAP. Mm-hmm. Impressive. So yeah, good job on the YOLO side. And let's just go quickly over OCRs. So you mentioned yesterday, you did mention that you were trying to go with like PyTesseract. Me and Dr. Nadia didn't quite like appreciate the idea that the first time I just suggested, like, gave you a little hint, maybe you could use them to take a look into the other methods. Like you found Easy OCR, Paddle OCR. There's also a Mem OCR, which like hosts a lot of different variations of optical character recognition and results from the Ukrainian numbers. I suppose there is something in Ukrainian NLP community. I could even look up for you if you have ever like this desire to experiment with that. There's also
Oh, yeah.
a pre-trained kind of embedding spot for our characters, like not even like the general numbers, but different numbers, like even the old ones. So that could be useful. But as far as also technical questions go, can you please show me the distribution of outputs on easy OCR?
Right. So the distribution of scores, right?
Yeah. So basically, it's obvious that in some cases it doesn't perform as well, but still majority is classified more or less in a decent way. And there's this like smooth transition, a reverse exponential transition from like 0.4 to 1.1 in this case. Can you please now scroll towards paddle OCR outputs? Yeah, so this seems like a very like more of a obvious gap between 0 and 1 here, like completely wrong outputs. There are a few of them, but they're still present, and they're like a big majority is correctly classified. Do you have any idea to why that may be the case? Like any intuition, maybe your thoughts?
I think maybe Paddle kind of polishes their output a lot more. Like maybe they do a lot more like after processing of the text or something like that. Actually, if we look in the pipeline, so in text recognition, like I have quite a lot of parts that come into this. Maybe that's why. Whereas in easy OCR, well, it's clearly less, I guess.
Easy OCR is just overall just an older architecture and approach to work with, but still works well. You can play around with it to get better results, but Paddle just smashes it completely here on this task in your some set. So good job finding that one. Yeah, and I do like the way you plot these like graphs and figures on the distributions as well as the examples, of course. So yeah, I don't think I have anything else to add or ask. Good job.
Thank you.
Yeah, I'm also fairly satisfied with the work that you have done. Like, and particularly that you took into account the feedback that Dmitry and me have given to you yesterday, like in a really short term, like really good job. But also you have managed to have an actual working POC that also generalizes beyond the set that you have trained on. That's like that's actually really, really nice. How much time did it actually take you to assemble the project?
So you mean like from yesterday to today, or like overall?
Overall.
Well, I mean, it was me and Alexandra.
Yes.
I wonder if we'd be able to give a very accurate estimation of this.
More or less. I'm just I'm just interested in general.
Well, in some, like if you sum the hours I put in and Alexandra put in, I guess it would be over maybe over 15 hours, something like this.
Yeah, I think like for the time like this, yeah, this is like a really, really decent job.
That's great.
Yeah, it's basically 2 working days. Like, good job, guys.
Thank you.
But also, again, like I want to make the similar comment to what Dmitry did. Also, a good job at looking at the graphs of the scores, and like it often gives you the understanding of the whether the pipeline behavior is healthy or not. What is, I guess, like it has been 15 hours, but still, what was the most challenging part for you, if there was any, or everything went more or less smooth? Just a second, guys. Sorry. Can you just a second? Sorry, guys. Yes. Yeah, like regarding the difficulty, what was the most difficult part for you?
For me personally, let me think. So, well, of course, there were moments where things weren't working and we had to figure out why they weren't working. So I guess like it's hard to like pinpoint certain things. I think overall it wasn't, there weren't any very major problems. Maybe Alexandra could name any.
There's no major problems for me, but I spent a lot of time when I prepare when I train YOLO, and also when I prepare the data set with license plates.
Yes, so the labeling, I guess, yeah,
Yes,
labeling took
yes.
some time.
Yes,
Yeah.
there was like license plates that I didn't sure what is the correct way to write this number.
That's actually another good point that I wanted to mention, because how to say, I see it quite often that some data scientists or computer vision experts, especially when they only start, they are not very keen on working with the data. It's only like models and pipelines, etc. So, but it's a necessary and really important part of our jobs. So like well done by saying like, no, we're going to label it and we're actually going to see the performance. Without the effort that you have done, so you, like, for example, you wouldn't be able right now to see this numerical results, and like without it, it's just like, okay, we have some examples where it's working and some examples where it's not working, but no way to really assess it. So good job into investing your effort into this, despite not having a lot of time resource. Really, really well done. I appreciate this.
Thank you. Thanks a lot.
No, it's important. Okay, like positive feedback. Good job, guys. No more comments from my side.
Yeah, so I'll stop sharing then.
Perfect.
Right, thank you.
Okay. Do we have the next group?
I think from from my group, it's me again.
Okay.
Okay, if you're interested, our results are not very different from what we had yesterday, because, well, firstly, Sasha, again, he has no electricity. But at the end of the day, model is too long to train, so I can present what we have for now and what we are expecting.
Yeah, exactly. Like, just walk us through your like kind of general thinking. Like, what was the plan for the project? How were you trying to tackle the problem? How were you trying to solve the problem? And where are you right now in the solving? Like, kind of like a checkpoint. What's the current state of the project?
Okay.
Like, don't be like, don't be too stressed about this. We just want to know, like, what you have done, what you have encountered, what are the problems that you're having, what are the thoughts that you're having.
Okay, so I will start. So basically, what the main idea and the motivation is to make detection of an object given already existing and trained model, which is not so obvious to do, given that you're restricted in using other models. the idea of implementing this was to run it through the videos of sheep or other cattle animals, but mostly sheep and dogs, to distinct them from one another. For this task, we used Yellow 5 model trained on Pascal dataset, like existing model. And as I said yesterday, the flow of the idea was like this. My teammate, he said, I have existing class model, and let us just see what we can do having just this. What we can do in terms of improving inference time. So one of the possible solution is to apply sparsification. Simply, it works like this. When we have a framework, we apply recipe, and then we have sparse model that is faster, smaller, and equally as accurate. This particular solution was suggested by this man on his blog. It was published this June 2022, so I thought that it's pretty actual, and indeed it is. He applied two methods of sparsifying, is pruning and quantization. And we were really impressed by the results he got at the end in terms of not only metrics, but increasing average FPS. This is the values for the video. So it's quite impressive when we get baseline and 8 cores, yes, 8 CPU cores. You got average FPS 21.91 and inference time 45 seconds. And then when he pruned and quantized this Yellow 5 small model, he got like 17 seconds, which is outstanding. So moving to the code, I'm gonna cover basic problems because when we inspired by this post, I can even show you how it looks. So basically it looks like this. It is very fancy and seems like it's easy to apply. However, the truth is that under the hood of this annotate py, he has a well-developed project, which is I assume that was developed throughout maybe a year or something. So lots of workings to do. But it is not the most important thing. The most important thing that the sparsifying was intended to apply by SparseML library, and it just does not work well with pre-installed models. By far, it requires the original data set, which is, I think, it's not what we're intended to do. So yeah, and when we finally understood the case of the problem, that the implementation of this tool is not what we're actually trying to do. We were like, okay, let us run it once again on this model. And it was too late. So it is still, I don't know, it was set to the training once again using the post specification when we are just dealing with existing weights of the model. I don't know, maybe there's more fancy way, because I think that, okay, I think we're gonna see if there is a more fancy way to do it without applying it on the data set. So what next? The demonstration is like this. When you have a video and the online, not online, we have the detection of an object. And also there were a lot of pretty videos of ships, but the model is still training. So for now, we cannot demonstrate any videos with actual results. The problem and conclusion is one big problem and a lot of conclusions.
So what did they, like you said, one big problem and a lot of conclusions? It's like it's a good point. Like, what are the conclusions that you can make after working on this project?
Okay, after working on this project, I personally can make a conclusion to read more carefully under the hood, because this this post was really promising and seemed to easy apply. So do more careful research. This is the first thing. The second thing, maybe delegate the tasks, because as I said yesterday, the person who runs the code and trains the model, for example, now, I don't know if he has electricity, probably not, because he's not meeting. So yeah, so to look closely, to do not, it's not in prep process, and is on the stage of preparing the project to see if it's really achievable and applicable, this technique to the current task, I'd say so.
Thank you, Michalina. It did like so, like yeah, like it was kind of like the promise was high. Yeah, the promise was high, but it happened. So that's why one of the reasons why, right, we try to develop in fast cycles, so to fail fast in order to move to other solutions. Okay, I will let Dmitro the floor if he wants to ask some questions maybe, or give some feedback.
Yeah, first of all, thanks for very inspiring as well presentation, because I do remember the first projects I participated in like a while ago, and there were also failures at first. And it's important to also realize whatever experience you encounter in life, like negative, very negative, extremely negative, or neutral, or good, it always is very helpful, especially if you reflect on it correctly. And from what I've seen, you did a great margin of job, like putting your effort into the research, into like formulating the task, like even the coming up with this idea to actually take the hardest track available, which is inference optimization, which is also a very non-trivial task, believe me. Doing all these, like you mentioned, specification, besides like pruning and quantization, there is also knowledge distillation, we wanted to ask about that, maybe I will. But this was good. Actually, well delivered presentation overall. It just you approach this with the tiny spice of humor and kind of like there's nothing to be ashamed of not delivering the complete results. So very well done. Even though like there are like no demonstration on the video, there are a lot of like lessons learned. That random dudes blogs are not like the reliable source of code, like especially something under the hood might be not working as you expect it to. And sometimes it's just safer to stick with GitHub repositories if you ever want like a quick demo of a reliable like model optimization technique or something. So yeah, thanks for that. The only question I have, I think, is it's like it's not gonna affect anything like the mark or else. I'm just curious. Have you ever like read some like information on quantization or not? As an approach. Because if I ask you a question, the next one, like for instance, the quantization means like you reduce the like floating points 32-bit to 8 like to ints basically, and maybe I just. You might not know the answer to the question, but I just want to know how the way you think on the solution to this to the problem. So we have a lot of layers in the network. We have the input layer and the output layer. We have something that's in between. What do you think is the most dangerous area to apply this kind of technique, quantization, removing the weights from like float 32 to int 8, like the beginning, the middle, or the end, or any of those, if you have any ideas, of course.
I personally at this point cannot even imagine why it's some cases it's more dangerous than the others. The dangerous, you mean in terms of like losing the metrics?
Hindering the model very badly.
Well, my intuition, I don't know the exact answer. I think maybe at the beginning, because it that like it involved in all the other computations. But maybe if the model is well balanced or something, that it's not the case. So.
Okay, that's very fair and reasonable. Actually, a very good guess. It's one of the parts that usually people avoid applying, like quantizing the weights. The same goes for the output, like feed forward part in the end. And what you are mostly focused on when you do this technique is like the middle part, where there's a lot of like pre-processing and like calculation, matrix multiplications going on. And if you lose some information there, it's like not a big deal. But thanks for that. No more questions from me. Sorry for that very tricky and hard question, but
no,
it was good to hear your intuition. Thank you.
Thank you for the question and for your feedback. It is really great.
I have one more question for you. Regarding the model training, because you said that the model is still training. Is it the original model or is it the pruned model that you're training right now?
No, it is a pruned model.
Mm-hmm.
With post I don't know, dealing with existing weights.
And what is the dataset that you are training in? Is it the custom dataset or is it
no? No, it is not. I think that it is this. It is still Pascal dataset.
Mm-hmm.
Because it's like the old model was trained on this, so in order to have like accurate, consistent maybe with the previous version of the model.
I see. I just wanted to tell you that indeed, like it's well, the pruning and the quantization of the model, they are difficult tasks that both like researchers and experienced machine learning engineering are kind of, they are working hard in order to achieve the speed up of the models. So like not completing this task to the very end, like there is definitely nothing shameful about it, because many people fail on it. So you're in a good company.
It's good to be. Thank you for your feedback.
So yeah, no worries about this, and I'm super happy that you have selected this topic and kind of like you touched it, and maybe so you learned about different ways of solving it, that like different ways exist. I know that Dmitry, you wanted to add something on the knowledge transfer or knowledge distillation.
No, never mind that. That's just
Never mind. Okay.
yeah.
Yeah, like I guess like there's another method that maybe Dmitry wanted to touch, but we're going to just I guess keep it for now. For detection models, it's actually probably there are some realizations for you. I haven't looked into this. I would expect to have them. They might be a bit less straightforward than for the classification models. Okay. I think we can move to the next group if there is one. If there is another group that is ready to present.
Good morning. I didn't prepare it. It's like a project because I remembered it and note that there is a Slack a couple of days ago, and in that time I just searched. I searched for terms that are, and search for some posts and information about them, but like project I didn't prepare. But I can in that way that Dmitry said, I can tell about what I learned, what I how would I do that in that way. Should I?
Yeah, please do. But again, what was your project? Can you start with this, because I didn't catch that.
I tried to and did choose the pose estimation.
Pose estimation. Okay.
In way it's like about human pose estimation, and first of all, to say that it's like a problem, and not many models are to solve that problem at the pose detection, and this is interesting in some way, and there are some methods for pose estimation, and most of them it's like an open pose, PoseNet, place pose, deep pose, dense pose, and deep cut. One pose that I detected, it's about the place pose. It's most of pose detection relies on CO topology, and they are consisting of 17 key points like dots that detected the pose. But the place pose detector, it consists of 33 human key points, like arms, legs, face, hands, and something like that. And I searched and for a model that made this method like place pose detector, and it used it used media pipe model of Python, and in this post there is a data set of yoga poses, and they trained this data set, detecting key points of pose. It has 33, as I said, in this model, and the results are not bad. And this detected data set consists of five of 6 yoga poses, and all of these poses are, and key dots of pose human was detected. And to say about another one methods, most of them consisting of 17 key points, and the plus is like it's making you to make the model and to train less time, and then are less lesser than this one. And in my project, if I will do it, it's try to compare time that try to do this model, because to try to don't know how to say, try to compose times that this model trying to do, and other ones. So something like that.
So just to clarify, because I'm not sure I got it correctly, your goal was the optimization of the inference time?
No, it's one of the metrics to do. It's to compose time, and other like how much KPU per percent it uses, and one that's easy to choose, and it's simply investigated is like time of training and time of doing the method.
And did you have the opportunity to actually like to play with the inference of some of the methods models that you have mentioned?
I didn't try to compose it and to by my hands to take is it works clearly or not.
Did you find it difficult to use? What was your what is the feedback on your experience?
Through what I learned, I didn't think that it's hard to use, but in case that in general, the reason why I didn't do it for this couple of days, because like people are preparing project for a long time, and it's like a project, and I get the information that if you didn't do it like project, it's on exam you should to talk about theory and something like that. In case of that, I think that it's wasn't very good to make a project on a knee like for a couple of hours, something like that.
Yeah, like no worries about this. Like Dmitry and me, I think like we're like at this point we're really more interested into your like into the progress into the project. So I see that you kind of have done the research into the problem itself and how like is it usually solved and some of the existing methods. So like that's a good point. But I would also like to hear what would be your next steps if you had more time. Let's say like you had like another month to work on the project. What would you do?
Okay, I looked for some like big data set. Then I will try to get this model like Blaze, what I learned, Blaze pose model to this data set, and I should get accuracy, how it works, time estimation, and something like that. And then I will detect other few models of post estimation, get their accuracy in time, and compare it all, and set like get some conclusion. Like for if you want to get less interrupted time, you should try this model, or if you want to get bigger accuracy, you should try to this model, and something like that. Off the top, interesting fact. I had experience of working at a company that works of annotation like images, and for a year ago, and I worked a couple of months with annotation, like every day of annotation, around 100 images. We worked on first, my project was like 3D models of human face, and our aim was to detect and annotate human eye at all. And when I started to doing labs and tried to going to do lab 6, when I should annotate my hand, I was I don't just said that I will do this one more time.
What like how were you doing the annotation? Just the curiosity, like what kind of annotation was it? Like was it annotation for the segmentation? Was it the pointwise annotation, bounding
At work?
box? Yes.
In project with ICE, we have like 45, I don't remember, dots, and each part of eye should have different couple of these dots, and distance between dots should be the same at all dots. In like you have to annotate брова, я не пам'ятаю, and all it has like as I remember 6 or 7 dots. You should try inner, outer, and dots between them, and all the distance between these dots should be the same, and it should annotate it in way they said it like don't go out of lines and something like that.
And what kind of did you have any any process of the verification? Okay, so you have labeled some images.
Yes.
What happened next?
Verification was first one is like I don't know how to remember it all, but this annotated our images. The next given to the person who типу, людина, яка вже підтверджувала їх чи ні. Якщо там було щось неправильно, то вона вже їх не підтверджувала. А типу, як метрики, якими це вимірювалося, перше це було default time. І якщо типу був default time, за який потрібно анотувати одну картинку. І якщо типу, ця анотація, ваша робота анотаційної картинки більша, ніж цей default time, то у вас коефіцієнт іде там нижче одиниці, якщо швидше, ніж цей default time, то більше одиниці. І друга метрика – це оцінювання, це була відсоток вірно проставлених точок. Тобто кожна картинка містила там 40 з чимось точок, і їх потім апрували чи ні. І далі всі ці там 10 тисяч, 100 тисяч точок, скільки з них неправильно були проставлені, і це accuracy, точність.
Тобто, якщо час анотування більший, тобто, якщо коефіцієнт анотування по часу більше за одиницю, це погано чи добре?
Ні, цей коефіцієнт повністю впливає на вашу заробітну плату. Тобто там є вага, там формула, з якої це враховувалось, типу більше впливав процент вірності, точності, але там, якщо він менше 95, то коефіцієнт сталий, якщо більше 95, то він типу більше становиться. І якщо процент називалось типу там програм тайм зразу вираховується, і процент так відносно цього часу, відносно задано. Ось так.
Але виходить, що точність валідувалася master annotator, іншою людиною,
Да.
яка перевіряла.
Да.
Окей. Добре. Окей. Так, з приводу проекту, так, наразі я вас позапитала, ви мені відповіли. Так, може, в Дмитра ще є запитання з цього приводу. Або тут може бути не обов'язково по проекту, може бути біля проекту. О, в мене ще одне запитання, потім спитаю. Дмитро, спочатку ви.
Давайте ви спочатку, бо я ще не придумав.
Давайте, да. Які ви знаєте, або можете придумати застосування таких моделей для pose estimation? Для чого вони потрібні в практичному житті? Може, не потрібні, може, не тільки для ресерчу потрібні.
Та ні, по-любому для чогось потрібні. Для чого? Якщо чесно, я не задумався над цим питанням.
У вас там був датасет з позами з йоги. Зачем? А навіщо? Як ви думаєте? Які ви знаєте? Можливо, навіть ви знаєте є такий комерційний предмет, який застосовує.
Pose estimation?
Да. І такі, пов'язані, дуже з йога-пози, взагалі такими спортивними позами. Ви його точно про нього чули, я впевнена 100%. От. Ну, може, ви щось інше. Про розумне дзеркало, яке...
Напевно, наприклад, використовується ж цей pose estimation, якщо в сферу геймінгу в VR, коли є ось ці два контролери, які тримаєш, і типу вони ж детектуються відносно твоїх рук, і можливо в цьому використовується pose estimation також якось.
Це класна ідея, насправді. Да, можна так використовувати. От використовують, тобто можна тренувати такого автоматичного персонального спортивного тренера, який буде вам казати, чи правильно ви виконуєте спортивні вправи.
До речі, про це. У мене є з цього кейс, нещодавно там проект був, ми там залучилися, там якраз типу професійний тренер, але ми типу для них робили, і робимо досі, один з ребят з моєї команди робить pose-estimation для гольфа і ще хочуть для бейсбола. Але на бейсбол поки не виділили бюджет, тому мене не взяли туди, і я зараз на інших проєктах, там допомагаю. А загалом, апка дуже крута. Береться відос, робиться на пару секунд, motion capture того цього гольф-свінга, і потім там розраховуються кути, твої всі правильність, твої постави, сила удару, дають тобі рекомендації. Це дуже-дуже прикольно. Це гроші там платять на заході. Тому а для бейсболу так тим більше, якщо зробити. Ось такі ось кейси.
Особливо актуально для видів спорту, там, де Ну, для різних видів спорту, але цікаво, теж цікавий стосунок. Ми його торкалися кілька років назад, наприклад, для фехтування. От, там, де відбуваються під час змагань, відбуваються якісь події, які відбуваються дуже швидко. І буває, що судді, буває проблематично зрозуміти, чи це відбулося чи ні. Тобто треба або в записі дивитися, або ж в такому випадку модель може, може автоматично визначити хід подій. Дуже зручно. Це така типу автоматизована допомога для судді або для тренера. От.
До речі, ще пам'ятав, на PlayStation також є гра, не пам'ятаю, як вона точно називається, Dance, якось там, де типу ти стаєш, відносно не знаю, як це фізично все працює, але типу там на екрані там можна для багатьох гравців, ти стаєш в позу, типу вона тебе детектить як людину, і ти повинен повторяти рухи, які на екрані, і відносно цього ти начисляються бали, ти ж саме позу маєш.
Є таке.
Ну, так, круто. Так. Да, є таке. Так, а в мене ще таке питання. Тобто, ви були одні, чи у вас були якісь тіммейти? Що стосується командної роботи? Якщо було, як ви організовувалися, ви якось обговорювали? Що було?
Ось я віднайшов те, що є канал Slack General, я був в ньому, а те, що був канал Confusion, я віднайшов це 3 дні назад. І рівно 3 дні назад я дізнався і згадав, що мені донесли, що в нас ще є проект по Computer Vision. Тому ніякої в плані відносно навіть тімейтів і так далі, на жаль, не було.
Окей, добре. Так, дякую. Було приємно поговорити на цю тему, однозначно. Це цікава тематика. От.
Якщо можна питання, там задавали одногрупники, що в них зараз немає світла, і от по CV, як далі, чи не на протязі дня, чи коли зв'язатися вам краще?
Я думаю, що ми зараз зробимо так. Ми зараз, напевно, по CV всіх заслухаємо бажаючих, і потім ми з Дмитром візьмемо невелику перерву, і ми ці питання обговоримо з ним. Як краще далі продовжувати. Добре? І ми ясно, що ми обов'язково скажемо і напишемо.
Добре. Дякую. Дуже дякую.
Чи є ще хтось з присутніх, хто хоче розказати? Perfect. If you want, perfect, you can start.
Yes, my project was license plate detection, and I optimized it for inference speed. The problem of license plate detection is to capture a certain area of the image that consists license plate of the car. It is a very useful task, as it is used, for example, to detect traffic violations. Also, it can be used for parking management. For example, allow only specific cars to the parking spots. Also, it can be used for highways to automatically find cars that runs on the highway. For the dataset, I chose a 2019 Kaggle license plate detection competition. It consisted of a total of 433 images. And also I did some pre-processing for the dataset. And after it, I had 600 training images, 61 validation, and 30 test images. For the preparation, I used 4 steps. First, I stretched all images to same format. Then I applied random rotation for images. Random rotation was from plus minus 10 graduses. It is used to make model more more precise about the angle of car despite of the image. Then I applied grayscale for 20% of images. I used it to make model independent of the car color. As you know, license plate generally is only black and white colors. And then I added a noise of to 1% of pixels just to make model more independent to noises. I used for training YOLO model. Also looked for the faster RCNN model, but I couldn't start it. So I just ran through YOLO, different versions of YOLO, and also YOLO v5 and YOLO v7. I trained it for about 200 apertures. It took me some time, especially when I trained it. I also got shadow banned by Google, so I had to create new accounts and train on them. For precision, I ended up with 5 trained models, but one version of YOLO v7 was lost due to technical problems. So to report, I got only 4 models. As you can see, the most precise model is YOLO v5M. YOLO v5M is the biggest model of all of them. It has around 29 million parameters. YOLO v5S is small. It is lesser model. It has only 7 million parameters, and YOLO v5 Nano only has 2.5 million parameters. As you can see, as expected, the biggest model has the best metric score. Metric is mean average precision, and the tiniest model also has the least precision. In this example, the most precise is YOLO v5 medium, and least precise is YOLO v7 tiny. For speed comparison, as you can see, it is correlates with model accuracy. The longest time to inference was YOLO v5 medium, and the shortest time was for YOLO v7 tiny. I can explain it by that YOLO v5 was previous iteration of YOLO, and it is expected that new versions of YOLO will have a better inference speed than previous ones. As a result of the models, the best model, I draw results for YOLO v7 tiny. As you can see, there are some false detections, but the most important is that the plate was detected. Here you can see a lot of false detections, but not for every picture. I think that's all I could make.
Okay. Thank you. Yeah. We are waiting for Dr. Nadia to reconnect. So I do thank you once again for the presentation. Alexander, do you have any teammates?
Yes, I worked with Max Sabadishin, but he only helped me. The most of work I did myself.
Okay. Have you tried optimizing the model somehow, in accordance to your task, like inference speed, trying those prunings or distillation or anything? Have you attempted
No,
those? Or?
I didn't make pruning or anything else. I tried to make a different version of dataset, but results were actually the same.
Okay. Can you go back to the slide? I don't remember. I think it's 8. No, it's way past. Okay, slide 11, please. So yeah, there's a good distribution of inference time in milliseconds here. And if you go back to slide 10, there's a good distribution of an interesting distribution of MAPs here. What do you think is like the most optimal model in terms of accuracy, like MAP/inference speed trade-off? I'm on these 4. Like
I think the
on
best
these
is YOLO V7 because the error between YOLO V5 and YOLO V7 is negligible, only 0.02. And in terms of speed, it performs a little faster, which can benefit in more FPS.
Yeah, for sure. So sometimes those 2% of MEP can be important, but if the performance is not that like big of a deal, for sure, YOLO V7 Tiny is the way to go. Okay. So out of curiosity, also a technical question: what were the difficulties with Mascar CNN? Why weren't you able to get it started?
I looked up for ready solutions for it to apply my dataset, but I couldn't start it. Just there was technical difficulties with it.
Several it's a very old architecture. I'm not surprised it is a big struggle to actually get that running right now. Pani Nadia will come back.
Sorry for the technical problems with the connection. Yeah, like I think I see the kind of right. So this graph and the one on the previous slide, I suppose, are the most important ones. So sorry for missing the end of the presentation. As I understand, you have compared like some. I understood from the first comment you tried with the Mascar CNN, but it didn't work. Yes. You tried? Okay.
Yes, I tried, but not this result.
Kind of based on the experiments that you have done, like what are the conclusions, or kind of what are the recommendations that you would give? So like, okay, like I'm the potential client that's coming to you, or maybe like you're a computer vision consultant and helping me to build the pipeline for the license plate detection. What is your like resume?
Future work and to improve inference speed, the quantization of parameters could be applied. Also, I could try a model with fewer count of parameters, and also prune some apply pruning to the weights.
Okay, but like among the models that you have compared, like which model seems to be good for what scenario? Maybe okay, if I want a model that's really fast,
As you
which
can
one
see,
should I be using?
from my experience and experiments, the best model with trade-off of inference time and precision is YOLO V7 Tiny.
Okay.
Yes, the precision difference between YOLO V7 and ULV5 nano and small is only a 0.2, but speed differs from ULV5 nano by almost half a second, millisecond, which in terms of FPS could grant a visible difference.
Okay, that's a good point. When you were doing the precision comparison, can we go back there? What actually? Okay, you were comparing the MAP.
Yes,
Okay, I see.
it is average MAP for test images.
I see. Also, like this is like a general comment which I think like we already talked about. Like the MAP comparison is, well, you have a single class here, so actually, okay, like it's maybe like it's not so bad, but still, like MAP is the average precision, right? So we average over multiple recalls, which means multiple thresholds. Whether in the like in real life in the production, most likely you're going to be using the single threshold. So you're going to be saying, okay, like this is the cutoff threshold. If you have a detection, like for example, the threshold over 0.3, we accept it, and then with the threshold below 0.3, we discard it. You see what I mean? Like MAP doesn't convert well into business metric, because like it's because it uses the average precision, but in reality you don't care about the average precision. You care about like some fixed threshold, and this which means fixed precision and fixed recall. Or put it another way, you can say, okay, like we can have a fixed target recall or fixed target precision, and then we can compare like the other one from the pair. But okay, no, but right now, good. It's more like a, okay, like I'm putting like this client hat, because if you come to me and tell me the MAP, I'm going to tell you like, I don't know what is MAP, and honestly, I don't want to know. I want to understand out of 1,000 cars, like in how many cars will you be able, like, will you actually be able to do the detection, you see? But like if you're, for example, talking to Dmitry, who like in this situation plays the role of your, I don't know, n+1 or n+2, yeah, so it makes sense to definitely to compare with respect to the MAP. Could you scroll a bit down, maybe? Like, can you just like show me quickly the slides, because sorry, I missed them.
Yes, this is the slides with experiments on test images. As you can see, model has some false detections, but on all images, the plate was recognized with the most probability score. The threshold.
So basically, you need to calibrate well the cutoff score.
Yes.
Okay, and I had a question, like when in the very beginning when you were talking about the training set, like I didn't understand this transfer from 400 something images to the 600 something in the training set. How did this happen? How did you get more images in the training than you originally had in your data set?
Augmentations, apparently. No?
Yes, it is same images, but a little different, like grayscaled, rotated, or noised.
But how did you like? Okay, like what was the order of the operations? Like you first did the split, and then you did the data augmentation, or first data augmentation, and then the split.
First data augmentation, then split.
Okay. What are the possible problems that this kind like order of the operation can like with potential problem disorder of the operation, so first augmentation then split, can bring? Why can it be problematic?
It may be problematic for test images because augmented images does not correspond to real image.
Yes, that's a good point. Actually, so both for the test and the validation.
Yes, test and
So exactly. So like maybe actually you don't want to augment your test and validation images, or at least test. Other type of the issue depends. Like everything depends on how actually you perform the split. If it's random, or like is there like some logic to it? Like for example, okay, I had one image and I applied some data augmentation to it. So like from one image, I have like, it has resulted in like 5 images with different type of the data augmentation. I don't know, like translation, rotation, grayscale, etc., etc. Then when I do the split, some of these images can go to the training set and some to the validation set. You see what I mean? But they are actually the same image, just augmented a little bit. They're not really different images. This is normally what you would want to avoid. So it's some sort of the contamination of your validation and test data set. You want first to do the split, and then on every part, like on the training, to do the augmentation, and then validation tests, so to discuss. But basically, you first do the split, and then do the augmentation. This is a better order.
okay, got it.
It's okay, in this case it's not such a big deal in this case because, as I understand, you have done it once and you have fixed it. So there's no problem for the model comparison. Even if your, say, validation set is contaminated, it's contaminated in the same way for all the models. Not a big problem if you are comparing like for the MAP. But if you are just trying to understand what is the actual performance of your model, like basically you're trying to make an estimation, like what are we doing when we're testing the test set? We're trying to guess what is going to be the performance on the new unseen data. So in this case, could be an issue because you're going to overestimate. You're going to be more optimistic than your model in reality. But for the projects that you have, again, so this has caused really no problem because you have a data set which is fixed. Okay. Another question regarding the YOLO. So I'm really happy that you have, so like now we see the YOLO 7. Like we have been seeing a lot of YOLO 5 for the last couple of days. And now it's YOLO 7. Did you try other YOLO 7 models?
Yes, I tried YOLO V7 small, as I remember, but weights of the model didn't save it, and I didn't try it again.
I see. As I understood, so one of the problems was the computational resources, right? So you said that you had to use the multiple accounts.
Yes, I could not use GPU on Google Colab on my account.
Okay. What are the kind of other difficulties that you had when working on your project?
The other difficulties is to make the YOLO actually train. I need to do some research on it, and also to make data set augmentations. And that's basically it.
And what did you use for the dataset augmentations?
I first tried to manually augment it, but it did not work well. So I used service, online service that makes it for me.
Again, which library?
I first tried to make augmentations by myself
Yes, yes, yes.
in the code,
And
but
then?
I used an online service for that.
Oh, online service. Okay, okay, okay. Thank you, Alexander. Like, I'm good with the question. Thanks for the presentation. So, I like the recommendation regarding the level 7. That is going to be all for now. I wonder if there are other projects left to present. Let me see quickly. Is there someone present who has not presented the project yet?
Yeah, it's me.
Yeah, I was going to ask. Okay. Okay. Tell me everything. Like, tell me what project you were working on. If you had the teammate, what is the state of the project? Like, do you have like an actual presentation, or are you going to talk about the current state of the project?
Well, I don't have anything, but I have just general idea of what I wanted to do. Well, my teammate decided to go to academic vacation, so I left alone. But well, so I wanted to make some project on human re-identification. As I understand, this is the same like object tracking. So I wanted to use some state-of-the-art algorithms, but there are some problems. The first thing is the best algorithm on object tracking is deep sort. It is based on YOLO. So when you drop a video to this algorithm, it makes some so it grabs features from detected images. But there is a problem. When you run your videos with this deep sort, it will run on all, for example, for all human on the video. But what if we want to run it for just one human on video? So we need to make some restrictions or something like that. So I was thinking about so how we can like обмежити область, на якій воно було б на якій би працював цей алгоритм. So I decided to like, well, I didn't run any code, but I decided to think about what if we create a bounding box around our desired like desired object. Then we can use some algorithms to track changes on some frames, and then we can use this algorithm deep sort on just one object. Да, якщо можна, я перекладу. Тобто у нас є алгоритм, який працює на всіх людях одразу. Це його deep sort алгоритм. А якщо ми хочемо тільки на одній людині це спробувати, то відповідно нам треба якось обмежити цю людину, на якій ми хочемо спробувати цей трекінг. І є така ідея, що ми можемо обвести bounding box навколо цієї людини, потім застосувати алгоритми, які аналізують як зміну точок у просторі. Потім за допомогою цих змін ми зможемо слідкувати за цим bounding-боксом, і відповідно ми будемо знати, і відповідно трекати саме цю людину. Не знаю, чи зрозуміло я це пояснив, але була така ідея.
То я так розумію, таки вашою метою був, тобто це був саме трекінг, правильно?
Як я зрозумів, re-identification – це саме трекінг, ні?
Не зовсім. Ці дві задачі, вони, скажу так, тобто вони споріднені, і деякі розв'язки можуть бути якби частково перевикористані, але це різні задачі. Тобто трекінг передбачає, що у вас якась є, скажімо так, просторова залежність або прив'язка. Re-identification, у вас, наприклад, тобто одна та сама людина, у вас там, не знаю, там на
Face ID,
одній камері. Так, наприклад, так. Так, тобто може бути взагалі в іншій ситуації спостерігатися, ви не можете попередньо. Тобто у вас може бути якась оцінка, може бути якісь є обмеження. Наприклад, у вас є vehicle identification, і у вас може бути якесь додаткове часове обмеження. Трекайте його на двох точках, ідентифікуйте точніше. І ви знаєте, що не може один той самий автомобіль з'явитися з різницею в 1 секунду. Там. Але в цілому передбачається так, що у вас апріорі немає прив'язки до часу або простору. Тільки з допомогою візуальних ознак відбувається identification. Все інше це вже допоміжне.
Я от знаю, що є такі алгоритми, там, наприклад, на основі кореляційних фільтрів, які, те ж саме, наприклад, от є там обличчя, яке потрібно там знати, да? От його ти обводиш, і потім алгоритм будує от в цій рамочці маску або там декілька масок, і в цих масках є, як условно кажучи, feature вектор, да? Тобто є там матриці ознак, які потім можна накладати на нові обличчя, і якщо вони співпадають, там більше якихось відсотків, то це та сама людина. А якщо не співпадають ці маски з новою людиною, то це не ця людина. В такому плані є такі алгоритми.
За допомогою ключових точок, правильно, наскільки я зрозуміла?
Там не стільки ключові точки зараз. Вони розкладають. Наприклад, я підношу там своє лице до Face ID, да, і там алгоритм знаходить моє лице, вводить його в рамочку для того, умовну рамочку, да, щоб там розуміти, що ми його там аналізуємо. Да. Потім це лице, ця картинка лиця, вона перетворюється у якусь там, або не маску, як це, або розкладається в якийсь вектор, або перетворюється, я знаю, що є такі алгоритми в ряди Фур'є, вони перетворюються такі маски. І відповідно у нас створюється на всі все зображення у нас перетворюється спочатку в якісь матриці, а потім в якісь там фічер-вектори, наприклад. І потім, коли підноситься там нове обличчя, то воно також перетворюється, і потім ці вектори порівнюються за схожістю, наприклад. Отак.
Яка метрика використовується по цьому?
Як це? Ну, типа,
Ну, і вірніше не метрика, а дистанція, давайте так.
ну там відстань, косинусоїдальна відстань, ну, щось таке. Тобто, ну, як схожість векторів. От.
Угу. Дякую.
Які застосунки практичні даної задачі?
Ну, по-хорошому, якщо ми от кажемо про обличчя, то це буде ж Face ID, там, наприклад, там при вході в офіс чи щось таке. От. Або ну, це не обов'язково, ну, тема була там Human Re-Identification, тобто таким чином можна, ну я просто не знаю, що в людях такого можна там, яким чином їх можна ідентифікувати, окрім обличчя, ну, там може відбитки пальців, там або там одяг, або щось таке. От. Тому ну, от, за всіма способами, яким можна реідентифікувати, там, то вона буде застосовуватися.
А може ви знаєте, чи у вас є інтуїція, якби яка найбільш така визначальна частина людського обличчя?
Ну, око, мабуть, там, ну, в плані того, що воно там, типу, унікальне. От.
Так, це абсолютно правильно. Тобто, якщо у вас є зворотня мета, і ви хочете якби обійти human identification алгоритм, то тобто вам перш за все треба якимось чином, щоб ваші очі не було видно. Тобто, грубо кажучи, надягнути темні окуляри. Окей.
Ну, чому ще можна обійти алгоритми з допомогою adversarial одягу, який пертурбує і все, і нічого не зрозуміло стає там для нейронки. Теж можна.
Так. Це тобто, використовують. Я поки що бачила тільки одяг, я не знаю, тобто, ну, точніше, це щоб робили капелюхи або щось таке.
Там різні паттерни вже і головне, типу, зменшувати, щоб не було все одно помітно. Типу. Бо раніше це була просто така огромна, типу, така плашечка, типу, плакат, потім це одяг, потім це там шляпа, ще щось. Ну, коротше, фантазують.
Так. Ну, і так, я думаю, що чим далі це буде ставати розвитку технологій великого брата. Це просто все більше і більш потрібно. Скоро, не знаю, з'являться стартап в Україні, який буде шити одяг з adversarial attacks. Я б не здивувалася. І я бачу, що ви... Окей, я зрозуміла, Микита, що ви пішли трохи в сторону трекінга, і ви згадали про Deep Sort. Чи дивилися ви ще на якісь інші алгоритми?
На нейронних мережах я взагалі нічого не знаходив, тільки от про цей. Але ну, мені здається, що він як найбільш типа продвинутий в плані, ну, як логіки, чому і за чим треба слідкувати. От. Тобто там знаходяться різні оці баунінг-бокси для різних людей, потім вони по-перше, там вимірюються за різними відстанями, за різними метриками. Потім оці от bounding-бокси, вони переходять в ці фічер-вектори, також порівнюються з попередніми кадрами. От. Тому, в принципі, ну, він як найбільш просунутий, наскільки я знаю.
Які в нього є, які ви можете недоліки назвати, так? Які можливі недоліки застосування цього методу відносно до, можливо, більш простих методів трекінгу?
Ну, по-перше, це те, що він на YOLO V4, наскільки я пам'ятаю, от, то ну, порівняно з іншими YOLO там, або іншими там, алгоритмами, він має гірший, як це? Ну, коротше, гіршу якість, або друге, це швидкість, бо це, ну коротше, для того, щоб алгоритм навчився, треба ж його вчити. От, і відповідно, ну там Є багато алгоритмів трекінгу, наприклад, на точках, які вимірюють чисто різницю відстаней, точніше, от між кадрами, як переміщується точка. І такі алгоритми, вони набагато швидше, там, в сотні разів, ніж на нейронних мережах. І я думаю, що це, по-перше, це YOLO V4, який вже старий, по-друге, це швидкість.
Так, в принципі, обидва хороші зауваження. Окей, і Deep Sort, тут я не була впевнена, тобто Deep Sort використовує ознаки, які видобуті з допомогою
спочатку YOLO їх ідентифікує, детектить YOLO алгоритм, детектить, наприклад, людину. І потім з цього bounding box він робить feature вектор. І тобто у нас є як унікальний вектор для людини. І потім його можна порівнювати з наступними кадрами і казати, це там схоже на цю людину чи не схоже людина. От за допомогою цього ж вектора схожості.
Добре. Бо це момент, в якому не впевнений, тобто використовується, яка модель використовується для feature extraction, для видобування ознак. У мене, якщо чесно, є сумніви, що це object detector, чи це типу окрема модель, яка просто використовує на вхід обмежуючі коробки, bounding boxes, отримані з допомогою YOLO 4. Але недолік цього методу, тобто ви правильно вказали, то він є просто-напросто дорогим. Да, типу він добре працює, але його використання дорогим. Плюс які потенційні проблеми, але це потенційні теж проблеми трекінгу в цілому. Треба дивитися, як вони справляються з новими та зникаючими коробками. Тому що в практичних стосунках це проблема. Як правило, в них є певна пам'ять, у вас коробка підвисає, коротше кажучи. Це окремий момент безвідносний до того, про що ми зараз говоримо. Окей, Микито, я зрозуміла. У мене, в принципі, питань більше немає. Дмитро, запитання? Якщо є ще. Добре. Дякую. Так. Чи є в нас ще хтось лишився? Так. Слав, Дар'я, Роман. По-моєму, всі, правильно? Всі, хто є, всі відповіли. Давайте зробимо так. Ми тоді зараз з Дмитром візьмемо перерву, поговоримо трошки про ваші проекти і взагалі, тобто, що ми будемо далі робити з приводу комп'ютерного зору для студентів, які сьогодні не були на іспиті, сьогодні і вчора. І потім продовжимо з машинним навчанням. Орієнтовно десь 20-30 хвилин ми вам просто напишемо в Slack, що повертайтеся, ми вас чекаємо. Добре? Добре. Все, я тоді прошу всіх, крім Дмитра, від'єднатися. Що, Дмитрий, як ви?
Блін, мені треба злити модель на Hugging Face, щоб потім не задеплоїти вже там закрити одну справу ще. Яку я дороблю. Я ніяк не можу. Ой, до речі, треба запис виключити. Я виключив. Я собі ще локально